We're on 2-3, as you can tell, and we're going to be talking about conditional statements, also called if-then statements. Okay, I'll just read as we go here. An if-then statement is a statement such as, if you are reading this page, then you are studying math. A statement can be written in if-then form is called a conditional statement. The phrase immediately following the word if and not including if is the hypothesis. The phrase immediately following the word then is the conclusion. Again, it does not include the word then. A conditional statement can be represented in symbol P and an arrow Q, which is read P implies Q. I don't use that actually. I always just use if P then Q. Okay, example 1. Identify the hypothesis and conclusion of the conditional statement. Notice the hypothesis is after the if, runs up to the comma, and then the conclusion is after the then. Example 2. Now it says to identify the hypothesis and conclusion, but you have to write out in an if-then form first. Okay, it starts off with you receive free pizza with 12 coupons. Well, what has to happen first is you have to get the 12 coupons. So you say if you have 12 coupons, then you receive a free pizza. Notice everything after the if is the hypothesis. Everything after the then is the conclusion. All right, so we got some examples here. Sorry about the slanted page here, but didn't take the picture too well. Okay, identify the hypothesis and conclusion of each conditional statement. If it is Saturday, then there is no school. Okay, so it is Saturday is the hypothesis. I have no idea what that thing is right there. And the conclusion is there is no school. Next one. If x minus 8 equals 32, then x equals 40. All right, the hypothesis is the x minus 8 equals 32. The conclusion is x equals 40. Number 3, if a polygon has 4 right angles, notice the hypothesis, then the polygon as a rectangle is C, the conclusion. All right, write each statement in if-then form. These are kind of hard. Some of these are weird, like number 4 here, all apes love bananas. Well, you have to come up with something, okay, that kind of explains what you're talking about here. So I wrote, if that is an ape, then it loves bananas. You could have said something like, if the animal is an ape, then it loves bananas, or something like that. You got to get a little creative sometimes. Number 5, the sum of the measures of complementary angles is 90. So the way I said it is, if the angles are complementary, I should have a comma there, then they add up to 90 degrees. Collinear points lie on the same line. If points are collinear, then they lie on the same line. Okay, determine the truth value. Truth value is true or false. Okay, if today is Wednesday, then yesterday was Friday. Well, that doesn't make any sense at all. If today's Wednesday, yesterday would have been Tuesday. So that is my counter example where I'm saying, no, not quite true. That's what it should be. Number 8, if A is positive, then 10A is greater than A. In other words, if you multiply 10 times whatever A was, it will be greater. And that is true only because it's positive. If it was negative, it would not be a true statement. All right. A couple more things to talk about. Okay, converse, inverse, and contrapositive. Okay, so you'll see the conditional, if P, then Q. Okay. Converse switches it, if Q, then P. The inverse has not P, then not Q. So you're taking the nots and putting them in for the original conditional. In contrapositive, that's the wacky one. That one you switch the P and the Q and you not both of them. Okay, now look over here. If two angles are vertical angles, then they're congruent. That's your conditional statement. Okay, now the converse is if two angles are congruent, notice we switch the if-then part, then they are vertical angles. Okay, the inverse, if two angles are not vertical angles, then they are not congruent. You put nots in both of the original conditional, and then the contrapositive, this is, you're taking the converse and put nots in If two angles are not congruent, then they are not vertical angles. Best way to remember it is this stuff right here. That'd be a good thing to put on your chart. Okay, statements can be true and false, and so can these things. That's basically what that paragraph is saying. So let's look at this. We're only going to do one of these problems here. I have three of them here, but only doing one. Write the converse, inverse, contrapositive of each true conditional statement, then determine true or false, and if it's false, give a counterexample. Okay, if you live in San Diego, then you live in California. Now our converse, we're just going to switch the two. If you live in California, then you live in San Diego. Well, that's false because lots of people don't live in San Diego but still live in California. So my example is you could live in LA. The inverse. Now remember the inverse. That's where we switch. We give nots to P and Q. We don't switch. Okay. If you don't live in San Diego, then you don't live in Cali. Well, again, that's not true. You could live in LA. Would make that counterexample. The last one, contrapositive. That's where we switcheroo and we not both of them. So we have to switch California and San Diego and give them nots. If you don't live in California, notice I put this one up front, comma, then you don't live in San Diego. And that is actually a true statement. All right. Talk to you later.